Hello students, welcome once again to our channel Score High to Soar High. In this video series, we have been uploading Tamil Nadu State Board Syllabus Class 12 Physics, Unit 2, Current Electricity, Physics Derivations. Today we are going to see the third derivation in this series. This is the part 3 of this video series. Come on, let us continue with our studies. Question number 3. Explain the equivalent resistance of a series and parallel resistor network. Answer: resistors in series. Here comes the diagram. We need to draw a neat diagram first. In this diagram, the resistances R1, R2 and R3, they are in an N-to-N connection. In other words, they are in a series connection. In this case, now let us take the analogy of a water pipe. A water pipe is there. In that water pipe, it is not cut or broken, so the amount of water flows in the water pipe remains the same, but as it flows, the speed may differ. So now we take the flow of water to current and the speed of water to the voltage. So in this case, the current remains the same in all the resistances R1, R2 and R3, but the potential difference, it changes. Here it is V1 and here it is V2 and here it is V3. By keeping these things in mind, let us continue to derive the derivation for this question. In all the resistors, current remains the same, but potential differences are different. Now let us write the equation for the resultant voltage. I mean potential difference. It differs, so V is equal to V1 plus V2 plus V3. In the next step, let me write the equation for Ohm's law. That is V is equal to IR. Here, as the resistors are in series, instead of writing R, I have written RS. S stands for series connection. In the next step, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Here, the current I remains the same in all these three cases. Now, let us write the equation once again. V is equal to V1 plus V2 plus V3 and substitute the values for all these. So V is equal to IRS and here IR1 plus IR2 plus IR3. I remains common in all these three terms. So let us take I out. So the equation becomes IRS is equal to I into R1 plus R2 plus R3 and I get cancelled. So we get RS is equal to R1 plus R2 plus R3. This equation is very important. Even if you happen to forget how to derive this equation, if you write at least this equation, you will get the mark accordingly. Now, equivalent resistance is equal to sum of the individual resistances. Now let us see resistors in parallel. Here is the diagram. Have a closer look at it. Here is a cell, and in this circuit, three resistors R1, R2 and R3, they are connected in a parallel manner. The resistors are R1, R2 and R3. Here also let us take the analogy of a water pipe. Here comes the water pipe. From this water pipe, 3 pipes are branched out. So a single pipe is coming. From that pipe, 3 other pipes are branched out. So what will happen? Water flows like this, and when it goes through these 3 pipes, what will happen? The amount of water flows through these 3 pipes, they become less or they differ. But what about the pressure at these 3 points? The pressure remains the same at these 3 points. Similarly, here the current gets divided. Here I1, here I2 and here I3. But what about the voltages? At these 3 points, the voltage remains the same, that is V. So by keeping these things in mind, let us derive the equation. In all the resistors in parallel connection, currents are different, but potential difference remains the same. So as currents are different, let me write the equivalent current as I is equal to I1 plus I2 plus I3, and here I is equal to V by Rp. How do we get this expression? From Ohm's law. V is equal to IR, therefore I is equal to V by R. So here, as these resistors are in parallel connection, instead of writing R, I have written R with a subscript P. So I is equal to V by Rp. In the next step, I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Here in all these 3 cases, V remains the same. In the next step, I have written again I is equal to I1 plus I2 plus I3. And in the next step, I have substituted the values for I and I1, I2 and I3. So we get V by Rp is equal to V by R1 plus V by R2 plus V by R3. In these 3 terms, V remains common. So let us take V out. So what do we get? Here V and V get cancelled. So the final expression becomes like this. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we can sum up like this. The reciprocal of the effective resistance, that is Rp, is equal to sum of the reciprocals of the resistance of the individual resistors. So this is how we need to derive this equation. So with this video has come to an end. Let us continue with our studies with another derivation in the next video.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.